I'm Dom from the Semper Group, and today I'm going to be showing you how to measure a cylindricity using the Opticline. So first I've loaded the part into the machine, as you can see. I've started a new program, and in this program I've created a length position and a rotational position, and that's just a reference for the machine to know what I'm doing. And then I'm going to click on measurement and click on live. So now it's in live mode, it will find that start position and find the angular position as well. And this just helps with making all our characteristics. So now I can click on cylindricity on the left, and at the top here I've got general, and now I can click and drag a box around the area that I'm interested in the cylindricity measurement. And then when I let go, it's created that cylindricity with 5 traces. If you're interested in a bit more detail, you might turn the number of tracks up if you're looking for more interrogation on what is going on and what the actual form is. We can get onto that later. So now when I press finish, you can see that the Opticline moves through the 5 positions, and it does so with both cameras. And once it's done, you can see that the cylindricity goes green. It's under 50 microns. This one is a 14 micron cylindricity. So now I'm going to click on Detail Contour and then click on 3D at the top. And that brings up a detail view. So if it's failed, we can then interrogate further what's going on with the form of that cylinder. There's a taper at the bottom here. So if maybe I had a 10 micron tolerance, this would fail. And I'm looking for that taper on the side there, and that would tell me what's going on. You can see there's a small, maybe a scratch or something on the side there where it's gone black. So what I'm going to do is I'm going to go into extract faults, and then I'm going to click value automatically, so it removes the scratches. I'm not so fussed about small scratches, and now you can see it's got a vastly different shape where it's removed all the little valleys. There seems to be a very small bit of dirt at the top there, but in general we're seeing this tapered shape throughout, which confirms what we already thought there. So that's how you measure a cylindricity. Okay, now I'm going to be measuring threads. So I've already loaded the part into the machine and it's in live mode. So all I have to do now is click on threads, and I already know it's the thread type, and it's a cylindrical thread, and that's obviously just a normal cut thread. So I just select the area of interest that I'm interested in. I know it's a sharp thread, I know it's metric, you can choose imperial if necessary, and then you can go into the different thread libraries, and I'm choosing M10. I know my tolerance band, and I'm just going to set that rotationally positioned to AREF there. So I'm interested in my major diameter and my minor diameter. That's the maximum and minimum diameters of the thread. Pitch diameter is at 50% material condition. The pitch length, so the difference between peaks and the length between valleys. The flank angles could obviously be turned on if you're interested in knowing if your cutter is maybe set for imperial or metric. 3-wire diameter is good for comparing between the Opticline and maybe a CMM. And the single value pitch is just a single length. So I'm just going to click finish there, and now it's going to measure those, and you can see it's got that length measured, and we can have a look at what's going on there. So most of it's good. The major diameter and minor diameter are good. The pitch diameter, we can just have a look on the detail contour. There's a bit of dirt on the thread there. Often threads do pick up dirt like that, especially if they've been treated. And you can see that maybe that, or maybe another factor, is bringing our pitch diameter out. It's just slightly too large. Maybe our cutter didn't go deep enough. So it's a good way to check what's going on with a thread there. Okay, now I'm going to show you how to measure the position of a full form of a thread, a leading of a thread intersecting with the major diameter. And this is useful for certain applications. So what I've got here is the machine in live mode and the part already loaded. And what I'm going to do is I'm going to click on length position and choose point of intersection reference. And the point of intersection is just where 2 features intersect. and I'll get onto what those two features are. So create a new reference, click on that, and I'm going to choose a diameter and general, and this is the diameter which will look for the major diameter of the thread. So I'm just choosing the major area of the thread, and you can see it selected there. I'm going to choose the measurement mode as interrupted. This will spin the part round and look for all the peaks passing through our traces. So we've got 5 tracks in this window, equally spaced, and it will interrupt those with the peaks of the thread. Choose a major axis and press finish. So I've just done that to align the axis of the part, just in case it isn't right in the centres. So next I'm going to choose a reference 2, which is going to be my angle. So here I can choose, in the top left I've got diameter, length, position, angle or rad. I'm going to choose angle, I'm going to choose general, and then I'm just going to choose where that lead-in, you can see kind of on both sides of the part, there's a lead-in angle in this area. And I'm just choosing that area, and then I'm just going to set my axis again to axis 01, which is the major axis of the part, and my measurement mode is interrupted. Again, this is so that the peaks just pass through that angle, and it joins the peaks up to make that angle. You'll see what I mean in a second. So I'll press finish there, and then it's created my intersection point P01. So where that angle and that diameter intersect, I just drag that to where I think they'll be, about there. Doesn't have to be perfect, but just approximate, and then press finish. So I've created an angle and a major diameter, and it's going to intersect those two to create that intersection point of where the thread starts, or where the full form of the thread starts. So it's just got to find quite a few traces there, so we'll just give it a few seconds. And it's intersected the angle and diameter there. So you can see that angle may be a nominal of 30 degrees. I can type that in so it doesn't go red. And that major diameter is not too important, but maybe again, I can just set the tolerances on there so it doesn't go red again. So that position, if I look on my detail contour, you can see it's joined up neatly where that lead-in has passed along the part as it's rotated. So you imagine as you spin a thread around, those peaks move along, and it's kind of joined up where they move along as it's rotated. And by joining those two up, it's created a fairly rough but accurate enough estimate of where that intersection point is on both sides of the part. And now I can use that to create a measurement. So that position will be measured from the end of the part. So general position, length position general, and click there. And that's just a normal length position that we've already covered. If you don't know about creating general length positions, we've got another video on that. Press finish there. I'm going to make sure that it matches the part axis, and then create a length from those two positions there. Now that might be 12 minus plus nothing minus 0.2 on this part. You can see that it's just intolerance. If you sort of measure this a few times, multiple times, you can get different numbers because this position isn't the best defined position, but a lot of drawings will ask for it just to check that the right number of threads are there. So you've got fairly loose tolerances on that. So today we've been using this bolt, so shoulder bolt, to demonstrate some of the features, and you can tell that it's got a centre at the top here where Allen key would fit, but it has no centre in the end there. And you can tell that this could cause an issue if you don't have the correct centres. So you may put a cone centre in the base, but then you'd need to use a female centre at the top. You can see in the machine that we've loaded in a female centre at the top, but you may notice, and I'm just going to grab our other one, that when we load it in, you can see how much that obscures the part. So it's obscured so much of the thread that at certain angles you just can't see the thread at all. And when you need to do a rotational feature like a run out, this can obscure so much of it that you can't do that measurement. And therefore, instead of that, we've used a chuck. And this is a 6-jaw chuck for the Opticline. And there are lots of options for centers. So for other parts where there's no center at all, you could just use a flat plate. And a flat plate will just, you rest the part on there and it will rotate. And it just uses the friction between it and the part to hold it. This is good for valve seats or bottles or anything else you can think of that has no features like that. For any domed parts, you can use female centers. This is a very small female center, and you can use any size that you like. We've got a very large one here too, for things that wouldn't fit on a flat plate and you don't have a center drilled in the end. So next I'm going to show you how to use the Opticline to actually load parts. So I'm just going to take this center out, and then whenever you put a center in the Opticline, you just want to make sure, for example on this center here, that you put a locking nut on the thread. So I'm taking the locking nut off a previous center, screwing it down, and then placing the center as such in the machine. And now it's in there, and I've unlocked the axis. That's free to rotate and hold any part that you like. Once that needs unloading, if it's a bit tight, you can just simply use a spanner, pop it out like that. So nice and simple, it's easy to load and unload centers. With the top center, it's just the same. You just give it a sharp tap on the side to unload, and then pop the other center in like that. And that will hold any part of the top as well. It's as simple as that.